Alright, in this section I'm doing section 4, chapter 1. In this section I'm learning about distance, the position, velocity, displacement, acceleration, deceleration, and speeding, acceleration and velocity. Distance, which is the time it takes to get to a place from one point to another. Position, the location. Velocity, the change in the position and its original location, and the final location, displacement, the change of an object's position, and original and final difference in the displacement. Acceleration is the change in an object's velocity. Either it slows down or speeds up. Reaction points and velocity, speed with direction. I'm also learning about graphing motions, the distance, velocity, and acceleration. Measurements, a change in velocity and acceleration of the cart on a ramp using the motion detectors. Constructs graphs of the motion of the cart on a ramp. Defining acceleration using words and an equation. Calculate our calculations. Speed, distance, time, using it from acceleration, and interpreting the distance, time, and velocity. Time graphs for different types of motions. I am going to answer the what do you think question. It says an automobile and a bus are stopped at a traffic light. What are some differences and similarities of the motions of these two vehicles as each goes from a stop to the speed limit of 30 miles per hour? And I said that if a car and a bus stopped at the stoplight and both take off at the same time, at the same speed, at a speed limit of 30 miles per hour, the car will be faster because its velocity is smaller, or tinier, however you want to put it. So its acceleration will be faster. Because the bus is bigger, its velocity will be slower. Like, for example, would you leave me alone? Go somewhere. Stop looking at me. You're making me nervous. We're going to draw a graph of what the bus and the car would be. If the bus and the car started at the same point, because the car is smaller, it'd go faster and have a faster velocity. Because the bus is bigger, it'd be slower because its velocity is not that much. And from the distance and time, the bus's time of taking off would be slower than the car's because the weight of it and the mass of the bus itself. Next, I'm going to talk about what acceleration means. Okay, acceleration, which is how fast the velocity changes, which basically means is if a car is going fast, and if a car is stopped, and then it goes, and it hits the gas, and is speeding up, it's accelerating forward, which is velocity. And the definition of velocity is how fast the object is going, its speed, and what direction it is going in. Okay, and you have a part of velocity that's called a vector, which basically means quantity is the quantity that both magnitude, size, and direction. Velocity is a vector. So going back to the example of the bus and the car, the bus's mass is bigger. Its velocity is going to be very slow because the speed of the bus it has a lot of weight to it, and the mass is big, so its velocity is going to be slow. As you take for the car, for instance, which is very small, and its velocity will be a lot faster. Sort of like, how do I put this? Like the example, the bus would be going slower because it's bigger, because of the car would be going faster because it's smaller. Would you leave me alone? God. I positively hate doing this. And depending on the way the automobile is changing, the velocity is either to speed up and increase the speed of the magnitude of the velocity, or to slow down and decrease the speed or the magnitude of the velocity. And when it turns, it changes directions, so the velocity changes, has a big change to it. Motions involve acceleration because velocity changes as time elapses. Now, acceleration, as I said before, is basically the points of where the object is starting to accelerate or go faster in its speed. Motions involve acceleration because velocity changes. There's also the opposite of acceleration, negative acceleration, the final velocity at the top of the incline that was less than initial, basically the object slowing down, which basically would be a positive acceleration versus a negative acceleration. Let's see, and solar quantity is a quantity that involves both directions and sizes, and vectors or magnitude is called a vector quantity. A quantity that has size but not direction is called a scalar quantity. Speed is a scalar quantity. It only indicates the change in the position over the period of time. Sort of like it changes the position when the object is going. Okay, so for example, like say in a diagram, if you see that the boxes are closer together, the object's going slower. Let me do that again over here. Boxes are going close together. It's fair. The boxes are spread farther apart. That means it's accelerating faster. So velocity and acceleration tie into one full. Now, describing acceleration, the way you would get acceleration in an equation would be the change of velocity over the change in time. That's how you would get the acceleration. And to calculate the acceleration, you divide change of velocity by change in time. The units for acceleration are A, and the units for change in velocity is the delta sign and the V. The change in time is the delta sign and the T. Units of velocity would be minutes or seconds or kilominutes. It's measured in seconds most of the time. The change in velocity is given in meters per second and kilometers per hour. The final units are simplified. They read either m s over s or parentheses m s parentheses s m over s squared or m/s. So starting how you would draw a graph for it would be, or another example, depending on the equation, because graphs tend to be different. This graph is the start to the finish. This graph is the velocity with respect of time. When it comes to a stop, this is if it's accelerating, if both vehicles are accelerating at the same time. Okay, using the equation for acceleration is defining the equation to the relationship between acceleration, velocity, and time. If you know the two, velocity and time, the change in velocity and time, and then you can find the acceleration. Basically like an algebra equation. There are also other ways you can use it in words. You can also do symbols. Here are some of the equations that you can use. Over A, or you can use the circle graph. And the big thing is velocity, acceleration, and time. Also, to find the change in velocity, you would do acceleration times the time, the change in acceleration, times the time, the change in time, over the acceleration, and you get the change in velocity. So, together, this is what I've learned in section 4, chapter 1.